All right, James. So for this problem, it's definitely more complicated than anything you're going to see on the test, because that 12 in the front is not a prime leading coefficient there. We're going to need to do a little more work if we're going to do the guess and check method on this one. So I would maybe suggest the AC method just for this particular problem. It's a chance to practice that other method and see how you like it, and it's going to work out a little nicer because that leading coefficient is not prime. But I mean, I think you got off to a good start with your answers to the first two parts of this problem. You start by multiplying your A, which is 12, times your C, which is 3. You get 36. You want to look for the two numbers that multiply to give us 36 and add, because of that plus sign right there, to give us that 13. And so you got the 9 and the 4, which are right. And then, you want to think about the signs of those numbers as well. And the plus on the end there tells you that the signs are the same, and the minus on the 13 tells you that they're both negative. So, and you had those numbers correct on the problem that you sent to me. So I think you were off to a good start with that. Okay, so how we use those is going to be a little different here. And the reason why we don't really want to use the other method is because 12 can be broken down into 1 times 12, 2 times 6, 3 times 4. If we're going to use the method, we're going to have to do some guessing and checking and potentially have to try like up to 6 different combinations of things until we find the one that's really going to work. So let's try the AC method for this one. So if we're going to use the AC method, what we're going to do is we're going to take our middle term, the minus 13x, and we're going to break it down into two pieces using the work we did down here. So 12x squared is going to stay the same, and the 3 on the end is going to stay the same. We're just going to break that middle term down into two pieces, making it look something like this. So that minus 9x and minus 4x, since they're like terms, you could just put them right back together, get right back to minus 13x. So we didn't change the truth of the expression here. It's still the same expression we had before. It's just rewritten to give us 4 terms so that we can group those 4 terms. There's my first 2 terms, and then there's my second 2 terms. Okay, and so my next step in this process is to factor these by grouping. So I'm going to look at the first pair of terms there and notice that 12 and 9 both divisible by 3, and then each term has at least one x in it. So I can take a 3x out of that term. Okay, and when I do that, it's like I'm taking the GCF out of that pair of terms. So I'm going to divide each term by my GCF there to see what's left. So 12 divided by 3 is 4. I've got a single x left in the first term. 9 divided by 3 is 3. I took my only x out. And I'm going to do the same thing for the second pair. There's less in common here, but every pair of terms has a 1 in common. And in fact, here I really want to take a negative 1 out. If my third term is negative when I'm factored by grouping, I want to take a negative out of there. So I'll take a negative 1 out, divide everything by negative 1. Okay, it'll basically just change all my signs and give me 4x minus 3. And the key for this to be going well, if this this is going well if those things inside the parentheses are matching up, right? I've got a 4x minus 3 for my binomial factor in each of these 2 terms now. And so, that is now my GCF. I can pull that 4x minus 3 out to the front. When I take it out of there, a 3x minus 1 is going to be left. Okay, and that's my factored form right there. So we just use, you do a lot of the same work that you did. You find your factors and your signs of those factors exactly the same way. The only difference is if we're going to do the AC method, we're going to take our middle term, we're going to break it into 2 pieces using the work that we did, and then we're going to factor by grouping, and it's going to get us to a nicely factored form. Okay, so hopefully this is helpful. Let me know if you have any other questions.